So we have two little examples using exponentials. This one, it says the new automobile costs $26,500 and depreciates at a rate of 17% a year. What will the car be worth 7 years after you purchased it? So hopefully now you understand we're going to use this equation. Now, just understanding what these things mean is like really crucial because we're going to put the actual numbers in here. So let's put up another equation. And we have 26,500. That's the initial value. And we multiply that by our rate, B. Now we got to find the factor. That's the factor. It's 17% a year. So it is going to be 1 minus 17 over 100, which is actually going to be 0.83. So you take all that, put in your calculator, you're going to get 0.83. Depreciates means it is decreasing, right? And then you're going to raise that to the 7th power, dealing with 7 years. And if you put that in your calculator, I'm getting 7191.05. So depreciate obviously means go down, loses value. And so that's doing just a typical problem with depreciation. This is exponential decay because it's decreasing every time period. And you know it's decreasing because that number is less than 1. So this one says the average household uses 960 kilowatt hours of electricity per month in 2019. Uses of electricity is expected to increase by 2.3% per year during the next decade. How many kilowatt hours will the average household use per month in 2025? So again, we are going to have our initial value times our factor. Now what's our factor? Let's put it over here. Our factor is 1 plus 2.3 over 100, which is going to be, if you put it in your calculator, 1.023. And I'm going to raise that to it's 6 years from 2019 to 2025. So I'm raising that to the 6th power, and I will get 1100.34. So that's what you can expect the average household to use per month in 2025. Typical problem. So we're going to look at doubling time and in the next slide, half-life. These are very common terms used in association with exponential functions. So first we'll look at doubling time. So let's say you have 5,000 in the bank and every year it increases by 8.2%. It's a mutual fund or bond or something. So that factor would be 1 plus 8.2 over 100, which is 1.082. So if I multiply this 5,000 by 1.082, I will increase the 5,000 by 8.2%. So I'm going to take that, I'm going to lock it. That's A times B, which is the factor, raised to the first power. Oh, no, I gotta put 1, raised to the first power, and then raised to the second, etc. Okay, so let's look at the doubling time. It started with 5,000, and when does it double? Just about a little under 9 years. That's how long it takes to double from 5,000 to 10,000. So it takes just under 9 years to go from 5,000 to 10,000. The question is, how long does it take to go from 10,000 to 20,000? And your answer should be just a little under 9 years, because the doubling time is always the same. So it takes the same amount of time to go from 10,000 to 20,000 as it takes to go from 20,000 to 40,000. And so 20,000 is about right here. 18 years, another 9 years, about year 27. Let's show it to you. There's a little bit more than 40,000. So that's true with all exponential growth. You talk about doubling time. So finally here we're going to look at half-life. So let's change this to month. So every month, the number of its parts per million, 10,000 parts per million in a solution of a pollutant is going to decrease by 16.8% due to runoff or whatever. So what do I need to multiply 10,000 by to decrease it by 16.8%? Now hopefully you know this now. It's going to be equals 1 minus 16.8 over 100. And that's what you'd multiply it by, 0.832. So I'm going to take 10,000, lock it, that's my initial value A, times my factor, and that's not going to change either, raised to, in this case, the first power. So that's the first 16.8. And now here's the question. How many months, because that's our time, does it take to go from 10,000 to 5,000? And it looks like a little bit less than 4 months. So now it's at, say, 3.5 months. So then how long does it take to go from 4,700 to half that, which would be 2295, and that's going to be 1, 2, 3, a little under 4 months, right? 4 months, little under 4 months to get to 5,000, a little under 4 months to get to 2,500, a little under 4 months to get halved again. So the half-life is about 3.5 months. And that doesn't matter whether you're going from 10,000 to 5,000, or way down here, you're going from 100 to 50. See, there's 1, 2, 3, and I can make that 28.5. And they're just about 3.5 months. So that's what half-life means.